IQ calibration. Phase and gain mismatch at the input would cause image signal at the output of the SSB mixers. In order to counterbalance these mismatch, an IQ calibration module is interpolated before the second SSB mixer. Fig.18 shows the circuit of this module. Two identical buffers driven by the in phase, 0 degrees, and quadrature phase, 180 degrees, signals produce two outputs, normally equal to 45 degrees and 135 degrees, respectively. Here, one of the outputs is adjustable, while the other is fixed. These two outputs are quadrature in ideal. If th. An interesting phenomenon using this method could be found. That is, the phase mismatch at the input will be transformed into the gain mismatch at the output, and the gain mismatch at the input will be transformed into the phase mismatch at the output. This could be illustrated by Fig.19, wherein N, I and N, Q represent the input in phase and quadrature phase signal, out, I and out, Q represent the output in phase and quadrature phase signal. It can be easily seen that the phase and amplitude error will be transformed into each other at the end. Hence, icon which adjusts the output phase will be used when there are some amplitude mismatches at the input, while icon which adjusts the output amplitude will be used when there are some phase mismatches at the input. This IQ calibration module should be capacitor coupled to the latter stage, since the output common voltage will be changed as the tail current is adjusted. When con or icon changes, the tail current source transistor should stay in the saturation region. Hence the drain voltage of M7 should be high enough to cover all the changes. Besides that, the VSAT of M5 should be high enough, because it will determine the range of the phase adjustable. As a result, the VGSD of the input transistor M1 is inevitably small. This will result in a severe third harmonic. A distortion cancellation technique is used here to ease the situation. An additional pair of transistors M3 and M4 is added to the input. They are cross-coupled to the output as to the main input pair M1 and M2. The VGSD of the main pair and the additional pair is set to be 1.6 to 1 while the tail current is set to be 4 to 1. The third harmonic could be effectively suppressed in this way, with the cost of a degenerated output voltage. Schematic of the IQ calibration. Illustration of the phase and gain mismatch translation.